The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. In recent events, NASA's James Webb Telescope has sent scientists another mind-boggling image, showing evidence of galaxies that aren't supposed to exist. These galaxies, which are older than our universe, are rattling the foundation of cosmology, making the Big Bang theory seem like a lie. Finding galaxies being born, and you could because it's infrared, it peers through nearby gas clouds. Stars are made of gas amidst the chaos. One scientist, who had a controversial theory that was initially rejected, is now seemingly the only one with the right model to explain this mysterious discovery. The James Webb Space Telescope is one of the most phenomenal works of science placed in the depths of space. Since its launch on December 25, 2021, and liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe. The James Webb Space Telescope has done a phenomenal job of helping scientists unlock some of the mysteries of the cosmos. Although earlier instruments allowed us to peek into the cosmos, none of them gave us a broad or deep perspective like the JWST. Thanks to JWST, scientists have seen mind-blowing galaxies and space objects beyond our expectations, revolutionizing what we thought we knew about the universe. In one such captured image, scientists spotted something shocking, something that shouldn't exist in the distant universe. James Webb captured some huge, mature, and fully formed galaxies that shouldn't exist. The fact that these galaxies turned out to be older than the universe made scientists call them universe breakers. Nobody expected these galaxies to be that old or to be at their location. Previous investigations and studies with earlier scientific instruments had depicted that particular space region as empty or void, so how these galaxies showed up is still a thing of wonder. Their presence defies the Big Bang theory and our modern cosmological model. All our cosmological models so far are based on the Big Bang theory, which states that the universe started as an explosion and expanded from what is called a singularity. After this single-point explosion, a series of expansion and cooling continued, during which time various objects in the universe like stars, planets, and galaxies began to materialize. The expansion continues today and is one of the universal properties that support the Big Bang theory. In fact, universal expansion helps scientists decipher a star's age in a galaxy. The idea of the Big Bang was birthed out of three facts, all represented in Einstein's general theory of relativity. 1. A universe that is filled with uniformly distributed matter or energy will most likely be unstable. 2. The only way the fabric of the universe can be stable is if it is configured to either contract or expand. 3. By observing some of the galaxies in elliptical in the sky and the distance they dwell beyond the Milky Way, scientists found a strange, unique correlation. The more distant an object like a star is, the more red-shifted the light from these objects appears to be. Thus, the redness of a star or galaxy as seen in our telescopes is directly proportional to its distance. With an expanding universe, objects keep moving farther and farther away from us. So, objects that didn't appear very red-shifted 1,000 years ago may only be visible on the infrared scale today, due to how red-shifted they've become. Scientists have, therefore, concluded that since the universe is expanding and becoming less dense today, it must have been smaller and denser in the past. Extrapolating even further, you'll find that in the beginning, our universe must have emerged from a highly dense core of unfathomable temperature and energy. In 1927, George L. It was not until later that other scientists independently reached the same conclusion. Howard Robertson concurred in 1928, followed by Edwin Hubble in 1929 and Arthur Walker a few years later. Over the subsequent decades, additional evidence about the Big Bang and its impact on the universe emerged. For example, scientists discovered that the Big Bang resulted in a remnant of low-energy radiation known as the cosmic microwave background, CMB. This CMB, often referred to as the afterglow of the Big Bang, dates back 13.8 billion years, making it as old as the universe itself. In addition to the CMB, it was observed that following the initial moments of the Big Bang, there was an initial abundance of elements. Over time, these elements gradually coalesced and reacted to form the complex structures present in the universe today. Other significant properties of the universe, such as dark matter and dark energy, were also identified and verified. Dark matter, an invisible form of matter, exerts influence through gravitational lensing, but does not collide with matter or photons. Dark energy, on the other hand, is a form of energy inherent to space itself and is responsible for universal expansion. Understanding these properties, along with the laws and interactions governing the universe, has enabled scientists and astronomers to simulate the initial conditions at the universe's inception and model its evolution to the present day. The Big Bang Theory, in its quest to address the complexities and conditions of that early epoch, has undergone several modifications over the years to accommodate new discoveries and features observed in the universe. However, the recent discovery from the James Webb Space Telescope, JWST, appears to challenge the fundamental premises of our cosmological model, causing unease in the scientific community. The detection of galaxies seemingly older than the universe has sparked controversy. Prior to JWST, the oldest confirmed galaxy in scientific records was GN's 11, located approximately 32 billion light-years away and with an age of about 400 million years after the Big Bang. However, with the operational commencement of JWST, over 100 galaxy candidates dating back to the first 400 million years after the Big Bang have been detected. These early galaxies possess unique properties that do not align with current cosmological standards and theories. They are massive, bright, rich in heavy elements, and appear to be actively forming new stars, which challenges existing models. The discovery of these ancient, massive galaxies with unexpected properties has raised questions about the validity of the Big Bang Theory in its entirety and whether aspects of cosmic evolution were overlooked or misunderstood. The anomalies presented by these early galaxies are sparking significant debate within the scientific community as they grapple with the need to reconcile these observations with existing cosmological theories. The recent JWST discovery has sparked controversy among experts, leading to speculation about potential flaws in our methods of deciphering the age of galaxies and the universe. Recent discoveries have prompted a debate within the scientific community, questioning current methods for estimating galaxy age and the accuracy of the universe's age calculation. Some experts challenge the traditional single Big Bang theory, suggesting the possibility of multiple Big Bangs, while alternative theories are being presented to explain the latest discoveries. The interpretation of redshift as proof of universal expansion is challenged by physicist David Rowland, who proposes that it may have been misunderstood as a result of the Doppler effect, casting doubt on fundamental aspects of the Big Bang theory. The existence of dark matter and dark energy, central to the Big Bang theory, remains unproven, leading to increased skepticism in the scientific community. Recent JWST findings have prompted experts to consider entirely new cosmological models and unconventional methods for estimating the universe's age, such as using the age of stars and globular clusters, are gaining attention. This ongoing scientific inquiry and discovery may lead to significant advancements in cosmological understanding, potentially requiring the reconfiguration of established theories and models.